Let's discuss the proposed model for this research. We have proposed this model. The first step of this model is data collection from the electric vehicle through the sensor data collector, or the sensors collect the data and deliver it to the base station. The vehicle sensor data is collected and the collected data is submitted to the base station. After receiving the data, base station applies differential privacy algorithm. Differential privacy algorithm protects the privacy of an individual while maintaining the usefulness of data. These algorithms are also guaranteed the behavior of the data set. The behavior of algorithm is hardly changes when an individual from the data set is removed or added to the data set. Anything the algorithm might output, the thing that algorithm might output with an individual is also likely to be the output without that individual and for individuals information. That's why it is very difficult to identify the presence of an individual in the data set. Okay, while using the differential privacy algorithms, we can also say that a mechanism FD is considered to be epsilon differential private if the probability of all generated output X differs only or equals to product of exponential epsilon and the probability of producing output X by the same mechanism with the dataset d bar. We can say for all X, the probability of generating X by the mechanism FD is equal to or less than exponential epsilon times the probability of generating X by the same mechanism with the dataset d bar. Okay, we can also conclude that if we have a data set D, then by varying the value of epsilon, we can create another data set D bar, which is very closely related to data set D. But it is very difficult to identify whether an individual is present in D or D bar or absent in D or D bar. Just that is the beauty of differential privacy algorithm. Okay, there are two types of differential privacy algorithm. First one is a local differential privacy and the second one is global differential privacy. We have applied here global differential privacy algorithm because the EVs are considered to be a less computational capable. That's why we have used here global differential privacy. After data is filtered through the differential privacy, data is compressed through a lossless data compression to optimize the space requirement or minimize the space requirement. We have tested with LZUTF-8, zlib, gzip, and dflet broadly LZ77 algorithms, and among them, broadly, LZ77 has performed best in order to compressing the data and decompressing it. After that, after compressing the data, we'll upload it into the IPFS. As data is already compressed, it will require the space very less. It will require space as less as compared to the actual data uploading to the IPFS. And after that, after uploading the data on IPFS, it will generate the content ID from the after uploading the data to the IPFS. Similar is at the same time we will also calculate or hash the actual data, which is represented here as hash 1 and hash 2. After that, we will combine the both the generated hashes, h1 hash 1, which is actual filter data hash, and hash 2, that is content id generated after uploading the data on IPFS. After that, we will store the data on blockchain using smart contract. Okay, that's a final step. But there is a small question: why we need to combine hash one and hash two? That is, storing the data storing into blockchain makes it immutable. We need hash one, hash two both. Hash 2 is the compressed data hash, the compressed data uploaded on the IPFS. From it, we can through this we can download data from IPFS. But after downloading, we cannot verify whether the data is same as uploaded one or not. To verify that, download, and then there will be a decompression, and then we will get the actual data that we have uploaded to the IPFS. Now we need to verify that it is the actual data or not. So we need to hash data, and after hashing we'll get h something. Let's suppose h1. Okay, and now we need to compare that hash 1 is equal to h1 or not. If both are equal, that means we have downloaded the correct data that we have uploaded to the IPFS. Okay, this is the overall method that we have proposed for secure the privacy security and the optimization of storage space. So if you have any kind of query or you have any kind of suggestion to improve this on this, we love to hear you. Thank you.